and Assalamualaikum. My name is Nur dan Makifah binti Muhammad Isa, and today I will explain about differentiation. What is differentiation? Differentiation is a fundamental concept in calculus that refer to the process of finding the derivative of a function. The derivative represents the rate of change of a function with respect to one of its variables. In simple terms, it tells us how a function changes as the input change. Besides that, differentiation is one of the two main operations in calculus. The other one is integration. Differentiation deals with finding the rate at which one quantity changes with respect to another. Next, I will explain about technique of differentiation. We have 8 techniques of differentiation. Number 1 is power rule. What is power rule? Power rule is d over dx, and in bracket x power n equals to n x power of n. And the power of x, we have to minus 1. Second is constant rule. Constant rule is d over dx in bracket c equals to 0, where c is a constant. Third one is constant multiple rule. d over dx in bracket c multiply f of x equal to c multiply f prime x. Next one is sum and difference rules. d over dx f of x plus or minus g of x equal to f prime x plus or minus g prime x. Next is product rule. If f of x equals to u of x multiply v of x, then d over dx in bracket uv equals to u prime v plus uv prime. The next one is quotient rule. If f of x equals to u of x divide v of x, then d over dx in bracket u divide v equals to u prime minus uv prime divide v power of 2. Next one is chain rule. Chain rule used when one function is inside another, a composition of function. If y equals to f g of x, then dy over dx is f prime g of x multiply g prime x. The last one is trigonometric derivative. First one is d over dx in bracket sin x equals to cos x, and if in the bracket is cos x, so equal to negative sin x, and if the in the bracket is tan x equals to sec power 2x.
Hi, my name is Farahia, and today I want to share with you guys how to solve this question. For the question 2, find dy over dx for the following function. Question A, y equals to 4x plus tan squared sin x plus 3. For the first step, we need to identify how many variables are there in this equation. There are 4 variables. First is constant, second is power rule, third and fourth is trigonometry. We need to solve all the variables one by one, and we got the answer is dy over dx equals to 4 plus 2 tan sin x plus 3, second squared sin x plus 3, cos x plus 3. And this is the final answer for this question A. Next, question B, y equals to exponential to the power of 2x minus 2x over 3x plus 1. First, we need to identify which rules we need to use to solve this equation. So, we need to use quotient rule equals to vu prime minus uv prime over v squared. The numerator is u and the denominator is v. So, u equals to exponential to the power of 2x minus 2x. When we differentiate, we got u prime equals to 2 exponential to the power of 2x minus 2. V equals to 3x plus 1. When we differentiate, we got v prime equals to 3. V squared equals to 3x plus 1 squared. So all the value we need to substitute into the quotient rule equals to vu prime minus uv prime over v squared. And we got 3x plus 1, 2 exponential to the power of 2x minus 2 minus exponential to the power of 2x minus 2x 3 over 3x plus 1 squared. And we need to expand the numerator, and we got 6x exponential to the power of 2x minus 6x plus 2 exponential to the power of 2x minus 2 minus 3 exponential to the power of 2x plus 6x over 3x plus 1 squared. And we got equals to 6x exponential to the power of 2x plus 2 exponential to the power of 2x minus 3 exponential to the power of 2x minus 6x plus 6x minus 2 over 3x plus 1 squared. and we simplify the equation, and we got the answer is 6x exponential to the power of 2x minus exponential to the power of 2x minus 2 over 3x plus 1 square. So this is the final answer for question B.
For the question 3, we must using implicate differentiation. Firstly, we must divide each for every dr part like a, b, c and d. For the question that we got, 2x over y plus 5 exponent 5x ln cos y is equal to 5x power of 3 plus 2. For 2x over y, we must use quotient rule to differentiate. Quotient rule is vu prime minus uv prime over v square. So we must make 2x as u and y as v. Then we differentiate u and v, and we will get u prime is 2 and v prime is 1. After that, we square the v, and we will get v square is x square. Then we put it into formula, that is vu prime minus uv prime over v square. And for a, we will get 2x multiply dy over dx minus 2y over x square. Secondly, for 5 exponent power of 5x ln cos y, we will put it for part b. For b, we must use product rule. Product rule formula is vu prime plus uv prime. So we classify that u is 5 exponent power of 5x and v is ln cos y. After that, we differentiate u and v. So we will get u prime is 25 exponent power of 5x and v prime is negative sin y over cos y, or we call it as negative tangent y. After put it into the formula, we will get 25 exponent power of 5x ln cos y minus 5 exponent power of 5x tangent y multiply with dy over dx. Okay, after we done for left hand side, we will do for right hand side. First, for 5x power of 3, we will put it into part c. For c, we will use power rule. Differentiate 5x cubed with power rule, we will get 15x square. Then for 2, we will put it in part d. For 2, we will use constant rule, so we will get 0. Lastly, we will combine a, b, c and d, and we'll make the green tick or answer that get dy over dx as a subject. So we arrange the answer follow as the equation. Then we will get 2x multiply dy over dx minus 2y over x square minus 25 exponent power of 5x ln cos y minus 5 exponent power of 5x plus tangent y multiply dy over dx is equal to 15x square. Then for the 2x multiply dy over dx minus 2y over x square, we divide for 2. After that, we will move the answer that no dy over dx to the right and factor for dy over dx to make it as a subject. So the answer that we will get is dy over dx is equal to 15x square minus 25 exponent power of 5x ln cos y plus 2y over x square over all that with 2 over x minus 5 exponent power of 5x tangent y.
Question 4. In this problem, we are asked to use linear approximation to estimate the value of the following equation correct to 3 decimal places. Step 1. We need to define the function. To solve this, we start by defining a function as shown on the slide and write it as fx. For the second step, we can find the derivative. Now we differentiate the function term by term, and we can write that as f prime x. Next, we use the linear approximation formula as shown on the slide. In our case, we want to estimate the value of the fourth root of 18.99 minus 2, all divided by the square root of 18.99. So we rewrite it as f of 81 plus f prime of 81 times negative 0.01. We got negative 0.01 by subtracting 18.99 minus 81. Next step, we substitute and simplify. Now we substitute everything into the formula. We have 3 minus 2 over 9 plus the result of the derivative multiplied by negative 0.01. This becomes 25 over 9 plus 31 over 2,960 multiplied by negative 0.01. The final step, after performing the calculation, we get the final estimate value. The answer is approximately 2.778, correct to 3 decimal places.